This is Dan, and this is the Napkin Academy. Our lesson now is 6x6 picture type, number 6. We've been all the way around our 6x6 sliced pizza, and we're to the end. Slice number 6 tells us why. The summary of everything we've seen up to this point, and the picture that we'll draw when we want to show or explain why is something that we're going to call a multivariable plot, which we're going to refer to here as an MVP or just as a plot. So here's the way that this comes about. We'll remember last time we looked at this, when we looked out at our little scene, our mind's eye went to work. And super quick review again. We saw who, we saw number, we saw location, we saw change over time, and when we added all those things up, we even began to see cause and effect. Well, now what we're going to do is we're going to put all those things together and say, from having spent this amount of time and this amount of cycles looking at this scene, what is it that we actually saw? Well, we're going to come away with two ways of representing that. In fact, for our Y picture, there are actually two pictures we can go. One is going to be very simple, and one is going to be very elaborate. And the simple one is going to be called a visual equation. The elaborate one is going to be called, that thing we talked about a moment ago, the multivariable plot. Let me give you a quick example of both of those. As we looked at that scene, an equation for what we saw might go something like this. Based on everything that we witnessed, we might be able to deduce from that scene that, wow, those dogs that we saw, that little doggy that we saw, dogs sure do love birds. Dogs love birds. But you know, the contrary is not true from what we saw, because it turns out, if we remap our dog and our little bird, that while dogs may love birds, birds do not love dogs. And there we have a visual equation summarizing everything we witnessed. Now, that's the very simple way of being able to show at the end of our scene what happened and have a takeaway underlying rule as to why did it happen. Well, because of this. It's what we call the equation. Now, the more elaborate way would have been to build a multivariable plot, and we're going to spend some time thinking these through, where we might say, let's compare dog activity to bird activity across a certain amount of time, or a certain amount of number, or a certain amount of position. Really what we're going to be doing in our multivariable plot is mapping together many of our very original six-dimensional coordinate system and seeing what happens when we find a way to map some of these variables together. Can we look for patterns that might have been hidden? Can we look for relationships that might be causal, that might just be correlation? That we can help understand why it is that every time we see a scene like the one we did, the same thing is going to happen. So, quick note, because I mentioned two very critical words. One is causation, and the other one is correlation. Now, if causation, of course, literally does mean that this caused that. Looks a little bit like our flow chart, doesn't it? Correlation means that this is parallel to this thing. And what we want to be clear is, just because things are parallel does not mean that they necessarily caused each other. So this is just a little word of warning that we're going to be very clear as we make our multivariable plots, that we're always looking for correlation, and what we're really trying to find is underlying cause as well. So, going through our specifics, our name, of course, is the multivariable plot, or simplified visual equation. This is picture type number 6, of course, and let's just come up with a little example. So let's say that we wanted to map out something about our business. And let's say that we're a company that sells products individually, and we also sell bundled products. And let's say that we've noticed that there is a dissimilarity in how many of the bundled products and how many of the individual products that we sell. So what we wanted to do is map out why that might be. So on this axis down here on our x-axis, let's go ahead and say that here are our unbundled products and here are our bundled products. We're going to compare those to each other. And what we're going to compare up here is, let's say, the percent market share that we have in our industry, that is to say the percent of the entire market that buys our products at all. And let's say that we're going to then map out how many products we sell along those two. So these actually represent amount of products that are sold. And so there we've got a rough outline of a multivariable plot. And what we're looking for is something that might tell us, interesting, our bundled products have higher market share and sell more than our unbundled products. What do you know? What we're trying to look for is, by mapping out multiple variables, can we look for some relationships between them? So multiple variables. Can we look for unexpected relationships between them that would not necessarily have been visible had we just mapped them out in some kind of spreadsheet? And so there's an example of a multivariable plot. Okay, so what does a multivariable plot show? Well, it shows the underlying y's, which is really the simplest way to think about it, a combination of everything that we'd seen up to this point, all bundled together. The coordinate system for a multivariable plot is typically an x-y coordinate system where we add in another dimension. Remember, the reason why we call this a multivariable plot is because we're not just comparing x and y, we're also comparing z's or a's and b's and c's and 1's and 2's and 3's. We're going to figure out some way to force all of these things together onto that coordinate system so we can look at the relationships between them. The starting point is we just pick any one potential axis, any one potential variable. Doesn't matter which one it is, really. We're going to be able to practice with all of them. Our starting point is just to say, what is a variable? And that could be some of the things we've talked about. Number of products, price, market share, any single variable, and then we're going to start to identify, after we've created our first, what are other potential variables that we might be able to map to it to find out something interesting. And of course, the relationships of objects within a multivariable plot are pretty complicated, but what we're really looking for is the object's overall interactions that illuminate some new insight. A lot of words right there, but what we're looking for is the relationship of things in their overall interactions. How does this variable align in a new way to this variable to another variable? That's what a multivariable plot does. As we can see, a multivariable plot is about the most complicated type of picture we've run into so far in any lesson, and that is going to remain true. This is the time when we're going to start to work with so many different types of elements and so many different types of layers that we're really going to have to take our time in thinking about when would we use a multivariable plot. And really, that's the question we want to have now. When is it worth putting in this tremendous amount of effort that's required to create a multivariable plot and have it be meaningful? Well, I think that there are 4 times when a multivariable plot is the kind of picture that we really want to focus on drawing. And as the name would indicate, multivariable plot, the first time is when we simply want to compare many different variables. And when we talk about variables, we just mean different ideas or parts of ideas or ways of looking at ideas. I like that one, ways of looking. So when we want to combine multiple different ways of looking, well, what does that mean? Well, let's just make something up here. Let's say that for some reason we really wanted to know if we could compare, I don't know, fish, um, trees, let's say sunshine, money, and see if looking at those four different unusually, apparently unrelated things, to see if there's not a way to look at them individually and together, and see if there's not some way to come up with some kind of mapping that puts them all together that might allow us to have some kind of aha that normally we wouldn't have just thinking about those things individually. So when we wanted to compare the four of those, somehow layer them on top of each other, well, the way we're going to do that, of course, multivariable plot. A second time we might want to use a multivariable plot is we want to get some insight. Get insight beyond the obvious. Beyond the obvious. Now, what do I mean? So let's say that we know, the sun rises, and then at some point the sun sets, and then the moon comes out. Well, that's obvious. That's the way it works. But what if we wanted to know a little bit more? What if we wanted to look beyond the simple process? And what would happen if we were able to create some kind of a plot that indicated, say, the stage of these celestial bodies in relation to some sort of cycle, and then we might be able to map them out according to some sort of cyclical format and see why it is that certain things seem to happen at certain times. So get insight beyond the obvious by creating a multivariable plot where we can map together the multiple different variables. Okay, well, kind of an offshoot of that is, looking beyond the obvious, perhaps we would want to make a multivariable plot when we want to look for unexpected relationships. Unexpected relationships. So in this case, let's just say that we've got a business and we've been tracking data for a long time, and we know something about our customers, and we know something about our products, and we could put those together and say, well, normally in a multivariable plot we could put down here, say, our customers, and we could map it to our products. And then what we want to do is look for something that's unexpected, not some one-to-one correlation, but maybe what we could do is map this in over time and volume. And perhaps if we did that, we could start to identify that there was some kind of trend that would not have been necessarily obvious in just looking at the cells and the tables in a spreadsheet, something beyond the this to that would only emerge if we were able to visually compare these two things to each other, looking again for the unexpected. Does something happen in here that we did not know was going to happen, and only becomes visible when we can look at it? Well, that's when we might use a multivariable plot. And kind of an offshoot of that one, which makes some sense, is, well, we can use an MVP when we want to test a theory. We've got an idea. Maybe there's something in the way our customers relate to our products that would be worth looking at in a new way. And so what I mean by that is, let's say we've got a theory that's derived from one multivariable plot or one collection of data that says our product, there's our product, very hard edges, is very appealing to, let's say, middle-aged men. But we've got a theory that our product could appeal to a younger crowd, and perhaps to an older crowd if we made our product a little bit softer, got rid of some of those hard edges. Maybe that would appeal to some of these other audiences. So what we might do then is create a multivariable plot to test that. And for example, we could say that on our x-axis, we're going to talk about age, and we'll go from young to middle age to elderly. And on our vertical axis, we might talk about hard-edged products to soft-edged products. And then what we could start to map in here would be, size of market. Maybe there's a big market there. Maybe there's a really big market there. Maybe there's a small market. They're just sheer numbers. And then what we could do is we could start to plot in, well, might there be some way from our data to illuminate a preference that might look something like this? Who knows? That might be kind of interesting. Can we test out that theory? Could we see if there's data that would support the fact that maybe a younger audience likes a softer product and a middle-aged audience prefers a harder product, etc. So, I mean, very, very conceptual, I recognize, but that's the kind of thinking that we really want to stimulate by using one of our multivariable plots. So, lots of theory, lots of elaboration, and so what I'd like to do now is move away from the theory and move into the real world by stopping this lesson now. Let's go ahead and stop this lesson now and pick it up in the next lesson and do a full-on real-world example of using a multivariable plot to help us test some theories, look for unexpected relationships, get insight beyond the obvious, while in the process of comparing many variables. So let's stop now and pick up there.